Week 14, lesson 1, this is on complex numbers. All right, so the essence of complex numbers is the imaginary unit, or I, which is considered to be the square root of -1. Okay, not a real number. It is considered to be imaginary, but we're going to be doing a lot of stuff with I. All right, so complex numbers have two parts to them. Okay, there is a real part, and there's an imaginary part. All right. And there's actually a way to graph imaginary numbers. So this is considered to be the real axis, and this other one is considered to be the imaginary axis. So, for example, if you were asked to graph 4 plus 6i, you'd have to go to 4 on the real axis, 1, 2, 3, 4, and 6 on the imaginary, 1, 2, 3, 4, 5, 6, and you'd have a dot right here. That specific dot is considered to be 4 plus 6i. Okay, so if I gave you this complex number and I said, what's the real part and what's the imaginary part? You would say, oh, well, the -3 is real and 2i is imaginary. Okay, and then likewise, if I gave you a number like 7, right? Just a random number 7, and I said, I need you to write this in complex form. Well, 7 is a real number, right? It's the real part. And this particular number just doesn't have an imaginary part. So this is the number that I gave you. This is that exact same number in complex form. Okay, likewise, if I said, hey, here's 2i, right? 2i, it's an imaginary number, but I want the number in complex form. You're going to tell me, oh, okay, well, that's 0 plus 2i, right? There is no real part, but there is an imaginary part. All right, continuing. So here, if it's saying name the real part and the imaginary part, well, we have a problem. The problem is this is not in the right form. All right. And the second part that's sort of a problem here is that I have this, which is considered to be a radical, in the denominator. So I'm going to rationalize this. I'm going to multiply the top and this bottom of this fraction by I. All right, and the reason that this is legal is really that's just 1. I over I would equal 1, and you can multiply anything you want by 1. So on the bottom, when I get I times I, right, I squared, that is -1. I squared is -1. And when you distribute here, we get I plus 2I squared. Okay, now keep in mind, I squared is actually -1. So now what I have is I minus 2 over -1. This is not the answer. Okay, I'm just trying to move my thing around a little bit. If I sort of move the -1, right, or distribute it to the top, I end up with 2 minus I. Okay, so the real part, because that's what this question asking, is 2. The imaginary part is -I, or -1, right? It's the coefficient in front of the I. Okay, next, a little bit of vocabulary here. Modulus is just the distance from, sorry about that, guys. It's the distance from 0. Now, remember how I showed you just a little bit ago how to graph these numbers? So think about if you were graphing 3 plus 4i. 1, 2, 3, 1, 2, 3, 4. It would be this dot. And we're trying to find the distance from 0. Can you see that we're going to have to do the Pythagorean theorem? Or in this case, we know that that one's 5. But that's where this formula is coming from. Right? It's just the Pythagorean theorem. Okay? So, scooting this up. All right? If it says find the modulus, you will be finding the distance from 0. You can graph it if you want to. But the formula is the square root of the real part squared plus the imaginary part squared so let's see, that's the square root of, if I add those together, 5/16. And if I take the square root, it's the square root of 5/4. That is the modulus, right? Or the distance from 0. Okay. For this problem, we probably should talk about what happens when you raise I to powers. Now, I'm going to do this kind of quickly. Those of you that had me last year, you will remember this. We did this last year. If you didn't have me last year, please ask me via Zoom, and I will do this in a much slower fashion. Okay? But what I want you to remember is that I equals I squared equals -1, I cubed is -I, and I to the 4th is 1. And then everything after that repeats itself. But probably the most important thing is every 4 i's that you see end up equaling 1. So to do this problem fairly easily, I'm going to just rewrite this into something in terms of I to the 4th, at least as much as I can. So I to the 4th raised to the 6th is I to the 24th, which leaves me one more I. Now, remember how I just said that I to the 4th equals 1? So in the parentheses here, I have 1 to the 6th times I, or 1 times I, or, look at that, I, just I, okay? Some much larger numbers are going to take a calculator. So if I take this exponent and I divide it by 4, in my calculator, I get 523.75. So I can actually rewrite this as I to the 523rd raised to the 4th times I to the 3rd. Okay, now again, you can always pause the video and double check that, but literally you just have to divide the exponent by 4, right? Because that way, all of this part equals 1. Okay, all of that equals 1. Okay, so maybe try this one on your own before I do it, because 873 divided by 4 is 218 1/4. So this is I to the 218 raised to the 4th, and then there's 1/4 left over, so that's just another I. All right, this equals 1. So what I have here is I cubed plus I. And then I cubed, right? I cubed is actually -I plus I. So this whole problem equals 0. Okay? But again, this is much, much easier with a calculator. Okay, so let's see. Sometimes your problems will be given like this. So what this is asking you to do is to multiply the first 2 complex numbers and then subtract the third. So let me fill in what I've got. 1 minus 3i. The second complex number is 4 plus I. And then I'm subtracting from that -2 plus 3i. Now you know order of operations, so you know that you have to do the multiplication first. So this multiplication I'm going to do, I need some room. So I may have to, I'm going to squeeze it in up here. I'm going to do it with a box. Okay, so I'm doing 1 minus 3i along with 4 plus I. So this is 4, this is -12i, this is positive I, and this is -3i squared, in other words, positive 3. Okay, putting 3 and 4 together, I get 7, and putting these i's together, I get -11i. Okay, so now let me get this back up, now that I've multiplied that. And now let me distribute this negative, so plus 2 minus 3i. And lastly, let me combine my like terms. Make sure you have this in complex form, meaning the real number first. So the answer here is 9 minus 14i.